Okay, now today we are going to start the second topic of the second chapter, that is organic synthesis, right? So in the yesterday's lecture, we learn about what is the selectivity of chemical reaction, then what are the reactants, products, and how they react, right? So even though we also learn about the some prime cause which are related to the chemical reaction, such as chemical selectivity, regioselectivity, diastereoselectivity, and also enantioselectivity also. So these are the important points with chemical reactions. And two more topics we learn in the yesterday's lecture, that is linear synthesis and the convergent synthesis. In case of linear synthesis, a series of sequence is there, and due to this the yield is of overall product is going to be decreases. While in case of convergent synthesis, the two fragments that are individually synthesized and then at the last step they are reacted each other and form a product. In this case, the overall yield of the product is going to be increases as compared to the linear synthesis. So the convergent synthesis is important as compared to the linear synthesis. So, but now today we are going to consider a multi-component reaction and the green chemistry. A part of green chemistry we are going to learn, right? So now let us start the lecture. So what is meant by multi-component reaction? Multi-component reaction means these are the convergence reactions. Convergent reactions means the reactants can be synthesized from different routes and then react with the final reaction and get the product. So these multi-component reactions are convergent chemical processes in which three or more reagents are combined in a such way that the final product retains significant portion of all starting materials. So here you can see that. A reaction vessel is there, and there are four reactants are there, right? So this one is aldehyde, this one is malonitrile, this is again cyclic ketone. So these are going to be react in a single vessel, right? So and they are four in numbers. So what is my multi-component reaction? Generally, reaction occurs more than three components. So here it is the four component is there, so it belongs to the multi-component reaction. And whatever the product is going to be formed, here it is we are going to use the four different reactors. So four component, right? And after the formation of this reactor, all these four components, the maximum incorporation of this molecule should be in the final product, right? So the loss is minimum in this case, right? And then we can go into consider that should be a multi-component reaction. So actually this type of reaction lead to the connection of three or more starting materials. Here it is, you can see there are four starting materials, right? One is in 2 mole, right? This malonitrile is in 2 mole, and while others are different. So these starting materials lead to the connection. They have a connection with each other, right? In a single synthetic operation with a high atomic economy. So the high atomic economy means whatever the elements involved in this particular compounds, they should be incorporated in the final product, right? So the loss should be minimum. And with high atomic economy and bond forming efficiency, thereby the increasing molecular diversity and complexity in a fast and often experiment simple fashion. So these reactions are short, require short time. Okay, and due to this, they are highly complex actually, but experimentally they are simple interactions. Okay, so now next you can see here, this is the one component reaction. One component gives one product. Second case, this is a two component reaction. Here it is, you can see two reactors is going to be react and form a one single product, right? And this one is, you can see here there are 6 components, right? 1, 2, 3, 4, 5, and 6. So there are 6 components in this reaction, and they are going to form this type of product. So this is not a multi-component reaction. This is also not a multi-component reaction, but this reaction belongs to the multi-component because it has more than 3 components starting material, right? Now, in general, so we can call it as any reaction in which more than 2 or 3 starting compounds reacted to form a product in such way that the majority of the atoms of the starting material can be found in the product are called as multi-component reaction. So you can see that this 1, 2, 3, there are 3 starting material and they form a product. What are the atoms involved in the starting material? They should be the part of the product, right? So then we can call it as a multi-component reaction, right? Next one is we are going to consider the first multi-component reaction, that is a managed reaction. So in this topic, we have 2 multi-component reaction, and the first one is managed reaction. So basically, the managed reaction is a multi-component reaction which involves condensation of non-enolizable aldehyde, a primary or secondary amine, and enolizable carbonyl compounds, which forms amino-methylated products, right? So this is the basic requirement of this reaction. It is a condensation. Condensation means the molecule will be coupled with each other with the removal of water molecules or any neutral molecules. Here it is, the starting materials are aldehyde. You can see here. This is aldehyde and this is also aldehyde, right? But the difference is that this should be a carbonyl compound. It means ketone or aldehyde. Here it is, aldehyde is there, and this is enolizable aldehyde. It means it should be CH2 group, CH3 group that can be formed enol form of this one. But now in the second case, this aldehyde is not enolizable. Means generally it is a without alpha hydrogen atom, and then we can consider it as enolizable, non-enolizable. Okay. Now third reactant is a primary or secondary amine. Here it is, there are 2 R groups, that means it is a secondary amine. And when these 3 molecules react, so they undergo multi-component condensation and they forms this type of beta amino carbonyl compound. And this is known as managed base. You can see here, right? So it is the simplest condensation reaction. We are not going to consider the mechanism according to the syllabus. We have only the description of this reaction. So kindly consider. So this is enolizable carbonyl compound, and this is non-enolizable carbonyl compound. And this one is a primary amine. These are the substrate which we are going to react with the amine, and they form this beta amino compound. We can call it as a managed base. Okay. So this managed reaction is useful method for the preparation of beta amino compound, which are useful intermediate for the preparation of beta lactam and beta amino acid. So these are the important product in industry for the large scale to form beta lactam and beta amino acids. Okay. So here it is, you can also see another example, that is, so here it is, you can see this is aldehyde ketone. So this is now enolizable aldehyde because it has alpha hydrogen atoms, right? While in this case, this formaldehyde is a non-enolizable aldehyde because they don't have any kind of alpha hydrogen. And this is the third reactant, that is a primary or secondary amine. So when this is going to be react, they form this beta amino compound, right? Here it is, you can see. So these 2 examples are similar. Only the difference is that here it is we are going to represent the aldehyde which are having alpha hydrogen atom. Okay, most of the time there should be a ketone, but the condition is that it should be a enolizable. Enolizable means it should have an alpha hydrogen atom, and non-enolizable means there should be no alpha hydrogen atom. Okay, now next one is Biangelli reactions. So here it is, this reaction. Actually, this is acid catalyzed reaction, which again involves a 3-component reaction between aldehyde, aldehyde. You can see this is benzaldehyde, beta ketoester. So this is a beta ketoester, and third one is urea. So you can see this reaction involves three components, right? So it is considered as a multi-component reaction. So, and when these compounds react, they constitute a rapid and facile synthesis of dihydropyrimidones. You can see here that this type of product is going to be formed. A cyclic reaction is there and they form a dihydropyrimidones, right? So another example is that the aldehyde is going to be substituted aldehyde, while in the previous case there is unsubstituted aldehyde, right? The benzaldehyde is there only, aromatic aldehyde is there. Here it is aromatic aldehyde is there, but there should be substituted. Now you can see substituted dipyrimidone is formed. Okay, dihydropyrimidone is going to be formed here. So this is the second example, right? Now next topic is the green synthesis. So what is meant by green synthesis? Green means the first thing is that the color should be a green, right? But it is not related with the green color. It is related with the chemical substances used in while performing experiments. So the green means we are going to utilize these particular compounds or reduce the hazardous substances or design chemicals that should be safe for the environment and human beings. So here it is, the Paul Naster in 1998 develops a set of principles that is known as 12 principle of green chemistry. So the green chemistry is nothing but the utilization of set of principles that reduces or eliminates the use or generation of hazardous substances in the design, manufacture, and application of chemical products. So this is the basic definition of green chemistry, which involves students should learn that, or they should understand what are the important things in the green chemistry. Green chemistry basically belongs to the set of principles, and that involves reduce or eliminate the use of generation of hazardous substances, right? While manufacturing, designing, or application of chemical products. Okay. Now let us understand what are the 12 principles of green chemistry. So here it is, I am going to represent the 12 principles. The first one is waste prevention. Okay. Second one is atomic economy. Third one is safer solvent and auxiliaries. Fourth one is the designing safer chemicals. Fifth one is design for energy efficiency. Sixth one is use of renewable feedstocks. Seventh one is catalyst. Eighth one is less hazardous chemical synthesis. Next one, reduce derivatives, design for degradation. And the next one is safer chemistry for accident prevention. And the last one is real-time pollution prevention. So basically these are the 12 principles. Now we are going to consider one by one in details. But okay, so here it is, waste prevention means whatever we are going to synthesize, during that we should minimize the waste or prevent the waste before forming, right? In the second principle, that is atomic economy. So in case of multi-component reaction, we learned that the whatever the starting materials is there or atoms involved in the starting materials, they should be incorporated into the final molecule, right? So then and then the atomic economy of that particular molecule is going to be increases. Means the percentage of involvement of all atoms in the product is more, then it means there is a generation of less byproducts. The percentage of byproduct is going to be decreases. It means atomic economy of product is going to be increases. The next, safer solvents and auxiliaries. While performing some experiments, we have to use the solvents which are safer. Just like as water is a universal solvent, it is a safe solvent. While benzene, if you use the benzene, that is a carcinogenic compound. So this is not the safe solvent. So use safer solvents. So next, designing safer chemicals. The chemicals should be designed. They are for hello.